Alright, this is problem 5-14 for AP Physics C Mechanics. So, the first question A is asking you, using the principle of conservation of linear momentum, determine the velocity v prime of the center of the mass of the rod after the collision. So, right now it's asking you to find this velocity right here. So, following the principle of conservation of linear momentum, as it tells you to do, we have, so first off, momentum equals mass times velocity. So since momentum is conserved, we can use momentum initial equals momentum final. So the initial momentum of the whole system is just going to be mass 2. So the momentum of mass 2 is going to be mass 2 times velocity. This is equivalent to momentum final. The total final momentum is going to be the linear momentum of mass 2 times, so the momentum of mass 2 times its final velocity, which is given to you by negative v over t. And then you're also going to get the linear momentum of the rod, and that's going to be equivalent to mass 1 of the rod times velocity prime, which is what we're looking for. So first I'm going to move this over here, and I'm going to get mass 2 times velocity plus mass 2 times velocity with the 1/2 out front. So I'm going to add these two together, and I'm going to get 3/2 m2 velocity equals m1 v prime. Now I'm going to divide by m1. So you should end up getting v prime equals 3/2 m2 over m1 times velocity. B is asking you, using the principle of conservation of angular momentum, determine the angular velocity, omega, of the rod about the center of its mass after the collision. Okay, so angular momentum can be, okay, so first we take the angular momentum of the system at the beginning. Angular momentum is mvr. Or it can also be expressed as I omega. So the total angular momentum of the system before the collision is just going to be the momentum of mass 2, because mass 1 is not moving. So momentum is mass 2 times velocity times its distance between the collision and the center of mass. Now, since the distance from the edge is L over 6, and we know we're dealing with just half of the length right here, we can determine that the distance from here to here is 2/6 L, which is equivalent to 1/3 L. So my R in this case is going to equal L over 3. Now my angular momentum for the final, it's going to have mass 2 again, but this time it has a different velocity, which is given to us. So I'm going to get m2 times negative 1/2 velocity times the same distance, L over 3. And now I'm going to add the angular momentum of the rod. Angular momentum of the rod is I omega. We're looking for omega, and I is already given to us. I'm going to substitute I later. So if we begin to solve this, I move this over to this side. So I'm going to get m2v L over 3 plus 1/6 m2 v L. I'm going to move this 1/3 out to the front. I'm going to go ahead and add these two together. And that's going to give me 1/2 m2 v L equals I omega. I'm going to move I down here. And then the original question gives me I is equivalent to 1/12 m1 L squared. So I'm going to substitute that in here. So the L is going to cancel out here and get rid of the squared. I'm going to move my 1/12 to the top. And then 12/2 is going to reduce down to 6, which should be your answer. Moving on to the last one, which is C. Determine the change in kinetic energy of the system resulting from the collision. So change in kinetic energy is equivalent to K final minus K initial. So the kinetic energy of the system initially is just going to be the kinetic energy of m2 because it's the only one moving. So it's going to be 1/2 m2 v squared. K final is going to be a lot more complicated though. First we have the kinetic energy of m2, which is going to be 1/2 m2, and this time it's going to be its new velocity, which is -1/2 v. Then we're going to have to add in the translational kinetic energy of the rod, which works much the same, 1/2 m1 v prime, which we already solved for in A. And then I'm going to have to add the kinetic energy, its rotational kinetic energy, which is 1/2 I omega squared, which we've already been given I, and we've already figured out what omega squared is. So, well, there should be a squared here. So this is going to turn into, so 1/2 squared is going to be 1/4 times 1/2, it's going to be 1/8. m2 v squared plus 1/2 m1. Now I'm going to substitute in my v prime, which I already solved for as 3/2 m2 over m1 times my v. So my m1s are going to cancel out. Oh, I'm sorry, I also forgot to square this. So this whole thing is going to be squared. So 3/2 squared is 9/4. m2 squared is easy. m1 squared, and I'm going to have a v squared on top. And now I need to substitute I. I is 1/12 m1 L squared times my omega, which I've already solved for, squared. So my omega is 6 m2 v over m1 L. So now I'm going to take this squared and just put it in here now. So I'm going to square it. 6 squared is 36, m2 squared is just m2 squared, v squared, m1 squared, L squared. so my m1 here and my m squared are going to cancel. My L squares are going to cancel entirely. 1 over 12 is going to give me 1 half more over 12 is going to give me 1 over 24. 36 on top, this is going to give me 12 over 8. So I'm going to get rid of all my constants and throw them out front as 12 over 8. Yeah, alright. This one, my m1 squared is going to cancel out with my m1 over here. And my 9 over 4 times 1 half is going to give me 9 over 8. So now both of these two are in terms of m squared, m2 squared, v squared over m1. Sorry, that m1 looks pretty ugly. So 9/8 plus 12/8 is going to give me 21 over 8. So that's my k final. So if I want to change this into my change of k, that's going to have to be k final minus k initial. And my k initial from over here is going to give me 1 half m2 v squared. These two are in the same term, so 1/8 minus 1 half is going to give me negative 3/8. However, this poses just a slight problem. This number is greater than this number, so my change in k is going to be positive. However, from the situation we're given, it doesn't make any sense for energy to just be coming into the system because there's no energy put into it. But there's a collision, so there actually should be a loss in energy. So I have to change the signs of both of these. So my negative 3/8 becomes positive, and my positive 21 over 8 becomes negative. And that should be the answer.